Alrighty, we're going to talk more about exception handling. So this lecture and the code that'll go with it cover the more advanced but very common usages of exception handling. We'll do one more video on this that will be the more esoteric type things. So just to recap, we have try, we have throw, we have throws, we have catch, and we have one more. We'll talk about it later, not today. So these are the important things. Now, you can do a try block, and a try block, so a block is called anything with the squiggly braces. So we can do a try block, and what we want to do is sort of put as much code in that block as possible that we want to execute. And if at any point in time during that try block something throws an exception, a new exception is thrown, we're going to go to the catch block. Two things. Usually, not always, actually, good programming will never do a throw inside of a try block and catch it. So you should never see this. Right? So you shouldn't try catch something that you throw inside of the same method. Right? So that should be something you never do. So this should always, the throw should always be something that you're calling a method on. And that method will throw the exception and catch it. So what we basically want to do is put as much code inside of this try block so we can, if at any point in time it fails, we go to there. It reduces the clutter. It makes the code a lot more simple. So for that to happen, a couple of things. We might have a method like this. Where we have a method that we declare, and it's going to throw A, B, C, and D, each of those being exceptions. Ultimately extending from what class? Pause. Throwable. Everything, if you can throw it, has to extend from throwable. So this says that we're going to throw A, B, C, and D. That also means somewhere we're going to have to write a catch block. Something like this, where we catch each of A, B, C, and D. So you have to, if this method could throw all of these, it has to be able to catch all of them as well. So what we're saying is, by looking at this method might throw A or B or C or D or none of them. And if it throws it, we have to catch A or B or C or D. If the classes are in a hierarchy like this, so D extension C, C extension B, B extension A, we can still list it like this. Perfectly fine. We might have a reason to. We could just list A if we wanted to. That's perfectly fine too. When we do the catch now, we have choices. We could catch A, we could catch B, we could catch C, we could catch D. We could also simply catch A, and it will catch D, C, B, and A because they're all extended from one another. Think back to the last lecture. Think about what I said about not catching exception and not saying that you throws exception. Here's why. If we said that this throws exception, right, that means we're going to have to catch exception. If we don't do that, the code won't compile. I will show you that later. What happens when you catch exception? Pause. Okay. When you catch exception, you're going to catch every single subclass underneath it. What are the two different, or what are all the four different kinds of the common exception names? Pause. So it's throwable at the top. Underneath that is error. Then underneath throwable as well as exception. And underneath exception is runtime exception. Which one of those are checked exceptions? Pause. So the checked exceptions are throwable and exception. And what does a checked exception mean? Pause. checked exception is one that the compiler forces you to deal with, which means the unchecked exceptions are ones that the compiler doesn't force you to deal with. Why do we have two different kinds of exceptions? Pause. So the reason we have two different kinds of exceptions is that errors and runtime exceptions indicate things that should not go wrong in a properly debugged program, right? So a runtime exception indicates that you made a mistake as a programmer, null pointer exception, or and extended bands exception. On the other hand, an error indicates something went wrong with the system. It didn't have enough memory for the virtual machine. It's trying to run a class file it doesn't recognize, that kind of stuff. So when we catch exception, what are we catching? Pause. We're catching every single exception underneath exception, which includes runtime exception. And when we catch runtime exception, we're doing something we're not supposed to do, which is catching unchecked exceptions, like null pointer exception and array index and bounds exception. So we never want to say that we throw exception, because we would never want to write that we have to catch exception, because if we catch exception, we're going to deal with all the things that should actually cause the program to crash. Here would be the controversial part, where I'm a purist and some people aren't. Some people find it difficult, find it annoying. It's not difficult, but annoying to keep the throws clauses up to date. It does, if you add to a throws clause, it means that all of a sudden, everywhere where that code gets used, it has to be updated. Now, there's a whole rationale for why you should not change the throws clause. That's another story, more advanced than we need for this course. But that's the rationale. They want to keep the throws clause up to date. So they'll either just say, I throw exception, or they'll instead have all their exceptions be runtime exceptions, and then they have to remember to catch them. But remember, I want you to be, for the lack of a better word, stupid. You're not going to pay any attention to exception handling and only do what the compiler tells you. The compiler is not going to tell you to catch runtime exceptions. Therefore, you shouldn't be catching them. Therefore, you shouldn't be extending them for things that you want people to catch. Therefore, don't do that and don't catch exception, because it'll catch them. Right? So this is why we don't ever want to say that we throws exception, because we'll have to catch exception, which will cause us to catch everything underneath it. Same thing, we don't want to say throws throwable. Right? There are a few very weird cases where catching throwable makes sense. You're never going to hit it, odds are. If you do hit it, figure out why you need to do it and make sure you thoroughly understand all the ramifications of it. If you don't understand the ramifications of it, don't do it. So you can have multiple throws clauses, you can have multiple catches. Another way, let's say A, B, C, D are all siblings under exception. So when we're going to say that we throws A, B, C, D, we can write catch A, this is the OR symbol. So what we're saying here is when we catch A, deal with it this way. When we catch B, C, or D, deal with it a different way. So if we're always going to handle these the same way, we can just do the OR. I can't even say that's relatively new, but that's was not in the original Java spec. So multiple throws, multiple catches. Catches can be combined. Don't catch exception, which means don't say that you throws exception. Simple set of rules. And try and do as much work as you can in the try block. There's another thing, which is also no longer new, but relatively speaking, to the age of Java, it's new, which is this thing called try with resources. So I'm going to give you some sample, really brief, badly written sample code. This won't even compile, don't worry about it. So we have this stream thing. There's input streams and output streams. They're for reading and writing from files and things like that. So just call it, say it's a stream. new file input stream or something like that. So we used to have to write code something like this. So we'd make the stream, we'd set it to null, or we'd declare the stream, we'd set it to null, we'd do new on it. That new could throw an exception. If it throws an exception, it's going to go skipping over this stuff. We want to do as much as we can in the try block. So it'll go from the constructor here, where it throws exception, down to here. S will be null, so we won't try and close it. Otherwise, we'll come in here and we'll go to read from the file. And if there's an error reading it, we won't do the close. We'll jump down here. S won't be equal to null. Oh, sorry, this should be S not equal to null. And it'll close S. Otherwise, if it comes down here, it opens it, it reads from it, and then it'll close it, and the catch never gets run. We're going to see this code again when we talk about finally, but the reason I'm not talking about finally right now is this is the most common reason why we use finally, and it's not used anymore. Okay, so this is what I used to have to write for years. They changed it. To that. Okay? And if I remember correctly, you just have to do a catch. So catch IOU exception there. So this is called a try with resources. So what we're saying is we're going to try to open this thing, and if it's successful, great. Otherwise, it'll go to the exception, and then we'll use it. And then at the end, hidden from us completely, it's going to call close. So this thing here, whatever you're creating, whatever this is, I believe the name, and I'd have to look it up, is closable. It has to be closable as an interface. It has a close method. I'll show you when we deal with the code. So the stream must be closable, which means it'll have a close method, which means that this code can execute that. This code here winds up compiling down to just what I showed you before, essentially. So this is what we call syntactic sugar. It's code that is there to make your life more easy. It generally doesn't change what gets run on the computer. It just makes your life easier as a programmer. So we've got try, we've got throw, we've got throws, and a method can throw more than one thing, and for each of those, it has to say that it throws it. We can catch more than one thing. We can do that 3 ways. We can write 3 separate catch or multiple catch blocks, 1 for each type. We can write a single catch block for the parent class, assuming they're all related, or we can use the or one, A or B or C or D. So that's 3 possible ways to catch things. And if we're going to deal with files or other things like that, we can use this try with resources that makes our code much simpler. That will, so the first lecture was here's the basics of exception handling. This lecture this is the common uses of exception handling. There will be code going along with this, and you get to see the code for that. And then the next lecture will be here are the corner cases of exception handling that you don't need to worry about typically. It's a short lecture. Okay.
So first off, I said I would tell you how to disable the hints. I'll show you the hints again just so we're clear. So if I have a method like this, that takes int x, of course make that final, not that it matters for this, but just good practice. and we call foo passing in 5, it puts that X colon, which some students find confusing. So we can disable these hints. I'm just going to disable it for Java. So under editor, inline hints, disable it for Java, and that goes away. So you're seeing what you're normally going to see. So there we go. So we talked about exceptions, and I'm going to show you the basics of. So we've seen the basics. I'm going to show you the more common things that you would wind up using. So multiple catches, multiple throws, all that kind of stuff. So let's go ahead and make a. Shouldn't erase that method. And we'll call that method. Now, we normally wouldn't throw runtime exception. For the same reason we wouldn't throw exception, it would force us to catch all the runtime exceptions if that's what we were going to catch it. But remember, this is an unchecked exception, therefore we don't have to catch it at all. The compiler does not tell us to catch it, so we don't deal with it, right? And it just crashes. If we change this to exception, it now won't compile because we have to add the throws. And the problem then becomes that we have to catch it. And we don't want to catch exception because that's going to catch all the children of exception. So let me just show you that right now. Run this. It looks similar. We get this stack trace. So I'm going to replace the stack trace with just hello. Okay. And if I throw a new runtime exception, which should cause the program to crash, it won't. It will say hello as well. Right? If I get rid of the try catch, because we don't need to have this throws anymore, which means we don't need to have the try catch anymore, and I run this, it will crash, right? But if I put in throws exception, then I have to do a try catch here because I don't want main to ever throw, because throwing in main causes it to crash. We don't want it to crash. So I'm going to surround it with a try catch. Back to what we had. So now because I said I'm throwing an exception, I've been forced to catch exception. And because I'm catching exception, then I need to, or I will automatically catch runtime exception. And it won't crash now, it'll print out hello, which is not what I want. And if we go and check runtime exception, we'll see that it extends from exception, right? Which is why when we catch exception, we're catching runtime exception. If we had a null pointer exception, same thing's going to happen. It's going to print out hello. That's because null pointer exception extends runtime exception, and runtime exception extends exception. So you've got this whole hierarchy. Right? The exception will catch every child underneath it. So that's why we never want to say that we throws exception, because something's going to be forced to catch exception, and then it's going to catch all kinds of things that it shouldn't be catching. So bad. Don't do. Do not do. Let's see what happens if we do this. So I'm going to use IOU exception. It's a common exception you're going to see. It is a checked exception. It extends from exception. So it extends from exception. It doesn't extend from runtime exception, making it a checked exception, which means we have to declare that it throws. No exception. And here's where things get interesting. And this is what I mean when I say don't do anything intelligent. Just let the compiler do it for you. I was told here that this method either has to do a try catch to catch that exception, and you should never do try catch to catch an exception that you directly throw. So if you say throw new, you should not be catching that within the same method. It should always go to whatever method called you. It's just considered bad practice. So because we're saying that because we're trying to throw an IO exception, the compiler is saying you didn't catch it, so you have to declare the method throws it. Okay, I can do that. Right? Now it says here you didn't catch it, so you have to either catch it or you have to declare that your method throws it. So let's be lazy. We'll use the throws again. And then the same thing here. You have to catch it or the method has to throw it or throws it. I'm going to mandate you never say that main throws anything. Therefore, you must do try catch around here. So that shows you how exceptions percolate up the call stack. Right? Every time you call a method, it adds to this stack of called functions. So another function, your method. Add car, and we will call car in here too. So what we're saying is we're going to try foo. If foo fails, it'll get the exception. We're going to try car. If car fails, it'll be caught in the exception, presumably. We don't know which of these methods is going to throw the exception just by, if I just see this code, all I can tell you is that foo or car throws IO exception or a child of IO exception. That's all I can tell you. I have to actually go look at the methods, and I see that foo throws IO exception, and car throws nothing. If, however, we're going to say that car throws throw new, I'm trying to think of something that isn't an IO exception, that is a checked exception. Security exception sounds interesting. Let's see. Nope, security exception is apparently a runtime exception of some form. Yep. So no such field exception is a reflective operation exception, which is an exception. For me, just so you know that I'm doing that shortcut, it's Control or Command B on my Mac keyboard. It's probably Control or Alt on B on Windows. I'm not 100% sure. So no such field exception is a checked exception. That means the compiler is telling us we have to do something. Well, since we're throwing it here, we're going to just say that it gets added to the method signature. And now, over here, car is being called, but it doesn't have a try catch. There are 3 ways to deal with this here. 2 really bad ways and 1 good way. The bad way would be to say that this method throws the exception. So let's do that. Okay, that's bad because now we're going to crash the program. Don't want to do that. The next way is I can surround it with a try catch block. It's almost never that you should put a try inside of another try. So probably stick away or stay away from doing that. It could happen, but it's really bad practice. I don't have any good use cases for that. It's legal, but it doesn't mean you should do it. We can add a catch clause, so we can catch it and handle it separately. But you'll notice that this one's highlighted, and that's because these 2 are doing exactly the same thing. And if they're both going to do the same thing, we may as well merge them. Right? So we catch an IO exception or no such field exception, and we handle them the same way. So all of those ways are possible. Another thing to notice is I don't have to actually have my method throw anything. It can just say that it's going to throw it. So you can add these in beforehand. Quite often it happens that you're extending or implementing extended class or implementing an interface. You're overriding this method, and the parent class requires it to throw an exception, but yours is never going to throw an exception. So you could have that throws clause, but never actually throw the exception. It's possible. So that's the basics of that. Let me do a different thing here. We'll make another main. So let me give you the real code that I was talking about for the file handling. Make it a reader. So a reader is how we read from files and things like that. So argv0, we'll see how you set command line arguments. That's useful to know. Argv0 will be the first argument that the user typed in after the program name. I'll show you how to set it when we go to run it. It's unhappy here because we are not catching the exception. So that's the bare minimum. Like if you don't know anything better to do, you just print the stack trace, but it's far better to give a proper error message. So this printf thing is a formatted one where it looks at these percent things. %s means it's a string, so I'm going to give it argv0. And %n, don't have to give it anything, it just means a new line. So this will read a character, and you'll notice it's going to catch an IOU exception. So it's just unhappy that I'm not using the return result. And we will close it. And we'll say here, well, there's nothing to close here, but there is here. And here comes the fun part, because close can throw an exception. There's a variety of reasons why close might throw an exception, but all you need to know is that it can throw an exception. I have no idea what you do if it fails to close a file. I know it's possible. I looked it up one day to find out what it can actually do, but in practical terms, I have no idea what you would do. Never been able to figure that out in 25-ish years. More than 25 years? I don't know. I started in 1995 for Java. I've had to do this since 1995. So, but there's our basic program, right? So we're going to open up a file. We're going to read from it, and we're going to close it. If we couldn't find the file when we went to open it, we're going to just print out we couldn't find it. If there's a problem reading or closing it, it will come here, it'll print out this message, and we'll try and close it, which might fail, and in which case I really don't know what to do. If we run this, it's not going to work. So why am I running it? To show you why it won't work. We've got an array index out of bounds exception. We're looking for the 0th item out of something that has no items. So we can't grab the 0th item. Right? That's the first item. So what we want to do is we want to go into here and say edit configurations. And each of your main programs will have that. So we want to edit main 2. And what we want to do, they've changed this. Program arguments, I will give it a foo.txt, and we'll see what happens with that. There's this working directory, so what it's going to be looking for is that's a completely bad place to put this file. I'll have to move it later. It will need to... Oh, that's okay, perfectly fine place. That's where I expected to see it. It will be looking for the foo.txt in this directory. So I'm going to have to just quickly go and do that. Actually, before I do that, we'll run it without being able to find it, and we'll see what happens. So my program arguments are here. I can enter in as many as I want, separated by space. This will become argv0. This is where it's going to look for files, and we're good. Should work. Can't find foo.txt. Right? So let's come in here and we'll make foo.txt. Now we can run it. And it finishes with an error code of 0. That's good. We can do and just break my rule here and call a method inside of a line, but that's okay for this simple little test. Should print out the H because we're reading the first character, right? H-E-L-L. Oh, let's see if it works. H-E-L-L-O. It's reading the file. It's that simple. If there was some sort of error, which it's hard for me to make an error happen, say that file's on a network thing and it goes, the network disappears, right? That could cause an IO exception. It'll come down and get caught in that. This is pretty verbose code, and like I said, I've had to write this for years. So they came up with a better way of doing it. It looks like that. So this is a try with resources. It's going to make this reader here. It's going to open it up. And if there's an error opening it, fine. In fact, I think what happens is if I take these away, it will be unhappy because it doesn't have the catches. So you still have to catch the exceptions. And apparently it doesn't actually need this file not found exception. Just happy with that. But we can keep it in because this will wind up catching. It will wind up getting caught or run. So we can run it again and see. Still prints out hello, and we'll come in here and delete it and run it again. And it says that it can't find the file. So it's still getting caught. So much smaller code, much less boilerplate, and you can focus just on the part you need to, not with that extra try and catch thing for the error and all that. So this is the preferred way to deal with files and things like that. So what you've seen is that you can have multiple... Oh, actually, I didn't show you that you can have multiple throws. Hop back here for a second. So we can also add a no such method exception. And here it's unhappy because we're not catching no such method exception, and we can just go ahead and add that there. Or if I want to treat it separately, I can, right? So these do not have to be related to each other. They don't have to be a parent-child relationship. They can be just anything. You can say that something throws more than one method. It can, or exception. It can just throw one. You can catch them. If we wanted to just have, do not do this, please. If we just wanted, and I'm going to show you something else that'll break when we do this. If we just wanted to catch exception, that's fine. But why is this red? Well, remember, this catches exception in all the children. Therefore, it can't reach these. Right? So the order of your catch blocks actually matters. So this will now work. It'll catch these exceptions, and any exception that wasn't considered will be caught here. But again, never, ever, ever write the words catch exception. It's wrong. But that is what it would do. It would catch these things, and then it would catch anything else that hadn't been handled. Same as this one here, we deal with file not found exception, which is a subclass of IO exception. So we don't have to have file not found exception because it's handled implicitly by IO exception. But I put it in there because I want to print out a useful message saying that it can't find the file versus there was a problem reading from the file. So that covers the basics of exception handling with the previous video. That covers the most common things you're gonna see with exception handling here, and there'll be again one more video of the ultimately just the finally thing, just to show you it working. Even though the finally thing is more, I would say more advanced, you still want to pay attention to that video. It's just less common, but that video is going to definitely tie together all of the code I'll write is going to be very comprehensive of the exception handling stuff, so you can get a feel for it.